You are falling toward Earth. Before you is a molten planet glowing crimson from end to end, its surface churning with orange-red oceans of magma. Even the surrounding space shimmers in the blinding heat. This is not the blue planet you know. This is the primordial Earth, 4.57 billion years ago. It was born from the collapse of the solar nebula less than 10 million years ago. Countless fragments of rock are still colliding and gathering in orbit, and every impact adds more material to the young Earth. You plunge into the atmosphere, surrounded by silicon vapor formed by the intense heat. The entire surface of the planet is still covered in molten silicates. At 2000 degrees Celsius, the heat vaporizes rock itself, filling the atmosphere with hydrogen sulfide, carbon dioxide, and water vapor. The moment you touch the surface, you realize there is no solid ground beneath you, only churning lava. Everywhere you look, the entire planet is a mass of molten rock. Even the wind is scorching hot. You look up. The sky is empty. There is no moon yet, only violent solar winds sweeping across the barren planet. There is nothing here worth staying for, so you turn the dial. The needle begins to spin. 50 million years later, 4.5 billion years ago, the sky suddenly becomes blindingly bright. A planet the size of Mars, known as Theia, is hurtling toward Earth. The enormous impact instantly blasts vast amounts of crust and mantle into space. The debris is thrown into Earth's orbit, where it continues to collide and gather under the pull of gravity. Eventually, it forms a newborn world, the Moon. An impact that nearly destroyed Earth has unexpectedly left it with a companion that will remain by its side for billions of years. It hangs only 15,000 kilometers above your head, with an apparent diameter 20 times that of the Moon today, like a red-hot copper basin suspended in the sky. Its immense tidal force pulls the magma ocean beneath your feet into waves higher than Mount Everest, sending them crashing against the crust before it has even fully solidified. The newborn moon immediately begins working overtime. It continuously draws energy from Earth's rotation, gradually slowing the wildly spinning planet. Deep within Earth, heavier iron and nickel continue to sink, gradually gathering into a scorching metallic core. The movement within the core begins to generate a magnetic field, shielding the young Earth from part of the solar wind and forming an invisible barrier around its atmosphere and oceans. Another 50 million years pass. Now it is 4.45 billion years ago. The lava has finally cooled into black basalt, and Earth has formed its first crust, a thin shell only a few kilometers thick on average. You step onto it. The ground feels soft beneath your feet and gives off waves of heat. Move slightly closer to a crack, and you can see the magma churning below. The early crust forms again and again, only to be torn apart and melted by impacts and geological activity. Earth seems to be repeatedly practicing how to build a truly stable surface. Meanwhile, volcanoes continue to erupt across the planet, and scorching lava repeatedly spreads over the older crust. With each cycle of cooling, this fragile outer shell grows a little thicker and harder. Through this repeated breaking and rebuilding, Earth finally begins to form a surface that can endure. You walk slowly along the cooling rocky shore. Raindrops begin falling from the sky, hissing into white steam as they strike the rock. You hold out your hand and catch one. It is acid rain. As Earth continues to cool, the water vapor in the atmosphere keeps condensing, and the rain continues for millions of years. The rain falls, evaporates, and falls again, until the scorching surface finally becomes cool enough to retain liquid water. The water gathers in low-lying areas, slowly joining together into an ocean that covers more than half the planet. When the rain finally stops and the sea gradually becomes calm, you glance down at your dial. It is exactly 4.4 billion years ago. Vast amounts of water vapor have fallen from the atmosphere and gathered on the surface, forming Earth's earliest oceans. The dark green seawater is still tens of degrees Celsius. Along the shore, lava meeting, the water sends up clouds of white steam. The entire planet looks like a gigantic hot pot bubbling away. For Earth, however, This is a true turning point. Liquid water can finally remain for long periods, giving many chemicals a place to meet, react, and accumulate. You continue walking across the rocks. Beneath your feet, the surface slowly changes from soft, sticky, and burning hot to hard and rough. By the time you finish this walk, another 120 million years have passed. It is now 4.28 billion years ago. You leap into the ocean and descend several thousand meters to a hydrothermal vent on the sea floor. Black clouds of sulfides erupt from beneath the ground at temperatures above 300 degrees Celsius. There is no sunlight here and no oxygen, yet the chemical reactions around you never stop. Lightning, ultraviolet radiation, and deep-sea hydrothermal vents continue to supply energy for chemical reactions. Simple molecules collide and combine in the seawater, only to break apart and rearrange themselves. Over immense spans of time, more complex organic compounds begin to appear, and the raw materials of life gradually accumulate. Within this inferno, where life seems impossible, a filament-like chain of single-celled archaea clings to the rock wall of the vent, quietly reproducing. Their structure is simple, yet they have completed one of the most important transitions in Earth's history. For the first time, a lifeless chemical world has produced life capable of copying itself and continuing to exist. Here, the first line of Earth's 4 billion-year epic of life is written. You rise back to the surface and rest against a rock, but the planet has not yet truly settled. Large numbers of asteroid and comet fragments left over from the early formation of the solar system are still colliding with Earth and the Moon. You watch as dense swarms of asteroid fragments rain down from above. Some strike the land, while others plunge into the ocean, raising waves thousands of meters high. Earth has barely formed, yet it must endure one trial after another, each nearly powerful enough to wipe its surface clean. Much later, when meteorites no longer tear across the sky so frequently, you arrive at the end of the Hadean Eon 4 billion years ago. The violent geological activity has gradually subsided, the crust has grown thicker, and the oceans can remain for long periods. The life forms hiding near deep-sea hydrothermal vents have also begun spreading into the wider ocean. The Hadean Eon has come to an end. This inferno, whose transformation across 500 million years you have witnessed, has now gathered all the conditions life needs: liquid water, organic matter, a magnetic field, and a stable crust. Over the next several billion years, life will transform this wild and barren world into the blue planet you know. Next, we travel to the age when life first began to change the entire world, the Hadean Eon.